all, today we are going to add and subtract radical expressions, and it kind of works like using like terms, where the variables and the radicals have to be similar in order to combine them. So this should be something that we should be able to take on and be able to do. So we are going to add and subtract radical expressions. If you see on this first page, I don't really have any notes for you to fill in. It's just kind of how to do it. But maybe this example would help. For example, if I have 3 to the square root of 5 and 4 to the square root of 5, both have a radical of 5. They can be combined. I can take the 3 plus the 4 on the outside and give me 7 square root of 5. Notice that the square root stayed the same. Also, I can subtract. And I have 2 minus 3, both with a square root of 7. So I can take that 2 minus 3, which gives me negative 1. And my square root of 7 stays the same. And note, you can write it as negative 1 on the outside, or it can simply be just a negative square root of 7. If there is no number outside here, it is implied that it's a 1. Now, if you want it to be a negative 1, there does need to be a negative sign. But if there's no number, no negative, it's implied that it's a 1. All right, so let's try some of these. We have 4 problems to try, and check it out in your book as well. All right, here we go. I get 7 square root of 15, 5 square root of 3, negative 3 square root of 15, and then minus square root of 3. I see I have some similar terms. I have a square root of 15 and another square root of 15, and I've got a square root of 3 and a square root of 3. That does mean I can combine those things. Let's start with the square root of 15. I have 7 square root of 15 minus 3 square root of 15. So I have 7 minus 3 square root of 15. And I'm going to write a couple extra notes here. And then I've got 15 minus, there's nothing there, which means there's a 1. So 15 minus 1 square root of 3. So let's do those things. I end up getting 4 square root of 15, and end up getting positive 14 square root of 3. That means I have 4 square root of 15 plus 14 square root of 3. Now, these two things could flip positions. I could have 14 square root of 3 first, plus 4 square root of 15. That doesn't matter. But you do need both of these terms there. Number 2 looks way more complex. Now, going back to what we previously learned, we first have to simplify these expressions. And maybe I should have said that in number 1. I had a square root of 3 and a square root of 15. I couldn't pull any perfect squares out of those, but I definitely can out of number 2. Every single one of these has some perfect squares to pull out. So remember, I'm going to pull out numbers like 2 squared and 3 squared and 4 squared. I'm giving you the answers here. 36. I'll go through 100 for you. 49, 64, 81, 100. I guess I keep going a little bit here because I got a little space. Yeah, 121, 144 is 12 squared. 169 is 13 squared. 196 is 14 squared. And 225 is 15 squared. So anytime I can use a multiplication problem in there to bring it outside, we're going to go ahead and do that. Now I'm going to make this look easy. You got to take a calculator and start dividing. Like 147 divided by 4, 147 divided by 9, 147 divided by 16, and on and on and on until you figure out what goes into it. I will tell you that 49 actually goes into this. So I'm going to rewrite these. So this would be negative square root of 49 times 3 minus, I'll simplify these in a second, 243, the biggest number of these perfect squares up top that goes into it is 81. So I'd have the square root of 81 times 3 plus 63 is a little bit of a smaller number, which is kind of nice. 9 goes into 63, and it's 9 times 7. And then minus 300, the biggest thing that goes into that would be 100 times 3. All right, so now let's go ahead and simplify these down. I'm going to take out the 49, and remember when I drop this arrow down, it turns into a 7. I'm going to cross it out, it's gone. So this is negative 7, it comes to the outside, remember, square root of 3. Minus 81 turns into 9. I can go ahead and cross this out. That 9 comes to the outside, so it's 9 square root of 3. And I have a plus sign. This 9 comes out as a 3. That's gone. I used it. I'm going to bring it to the outside. I took the square root of it. 3 square root of 7 minus 100 comes out as 10. Comes to the outside, so 10, and I've got a square root of 3 left. I see that I can combine 3 of those terms because there are 3 square roots of 3. And that's great. I can do this one, and this one. Now that one that is square root of 7, that one's just going to stay in the answer at the end because I can't combine that. But I have negative 7, let's do the math together, minus 9, minus 10, negative 7 minus 9 would be negative 16, minus 10 would be negative 26. My radical stays the same with the square root of 3 in it, and I'm left then with this last term that I can't combine with anything because it's not like, plus 3 square root of 7. That's kind of complex, and you've got to be able to find all those perfect squares to simplify the radical expressions down as far as they possibly can go. All right, let's take a look at number 3. In my radical and under it, I have 11t. Can't be simplified. Kind of nice. So now I can go ahead and look if I have like terms. I have 15t and 7t. Those are like terms. I can combine those. If I combine 15 and 7, I'd get 22t's. Now, I have 3t square root 11t and negative 1t square root 11t. I can combine those. Let me give you a real quick though. If I had 11t and then I had just an 11, those are not like terms. The variable part even has to be the same to combine. But I can combine these. So I end up having 3t minus 1t, which would give me positive 2t, and my radical stays the same. And that is my final answer. All right, let's do the last one together for today. Number 4, again, kind of complex, some bigger numbers in there. I think I'll quick give you my rundown one more time in case you want to write this down. 4, 9, 16, 25. These are perfect square numbers. 36 in order. 49, 64, 81, 100, 121, 144, 169, 196, 225. That is all the numbers through 15 squared. Now, obviously, you can keep going. But that's what fits up there right now. All right, so let's break these down a little bit. I need to simplify these down. So I'm going to rewrite them as multiplication problems right now. Can't lose that 4y on the outside. 242, looking up at those squares, the biggest one that actually goes in is 121. It's 11 squared plus 3 square root. Now, we'll worry about the y to the 6 in a minute. Let's fix the 18. That's 9 times 2. And remember, we can pull out even numbered powers, and y to the 6 is even, so we'll be able to pull that out. Plus y to the square root of 50, that's going to be 25 times 2, because that's the biggest perfect square up there that I can pull out. Minus 5. 32's perfect square would be 16 times 2. Y to the 6th. All right, it's going to get a little messy, so I'll try to write as neat as possible for you. Let's fix these. 121 becomes 11. And I need to go, I can't do anything with the 2. The 11 has to get multiplied here, so I'd have 44y on the outside, square root of 2. Plus, 9 comes out as 3, so that's gone. The y to the 6 also comes out as y cubed, so that is going to be gone. Those are going to get moved to the outside. 3 times 3 is 9, y cubed, square root of 2. Okay? Then I am left with 25 becomes 5. So 5 is going to get out here, plus 5y square root of 2, minus sign. 16 comes out as 4, and y6 comes out as y3, so minus 20, y cubed square, just cross that out, square root of 2. Now I see everything is a square root of 2, but that does not mean everything can be combined. I have y's, and I have y cubes. The y's can go together and the y cubes can go together, but that's all we can combine. We can't go more than that, even though they're all square root of 2. So let's combine our y's first. 44, oops, let's change it back to black. 44 plus 5 would give me 49, and those were both y's, square root of 2. And let's combine our y cubes. 9y cubed minus 20. would give me negative or minus 11, and those were y cubed square root of 2. All right, that is how you add, subtract, multiply. Just kidding. This is how you add and subtract radical expressions. Simplify them down as much as possible and find like terms. Good luck with that. Miss you guys. Hopefully I get to see y'all very soon.